Section 1.9 is going to continue your work with algebraic expressions. This time what we're going to do is simplify algebraic expressions, try and write things in a more compact form, simplified. And this is, again, warming up for stuff that you're going to do in section 2 or chapter 2, which will be working with and solving equations. We'll start with problem number 24. Thank you. Nine times 3s. I try and write my s's a little bit smaller than the rest of my numbers, and just for comparison's sake, there's one of my 5s. I try and make that little sharp edge there so you can tell it's a 5. In any case, 9 times 3s. What I would expect simplified here is the 9 times 3. 9 times 3 is 27. So 27s. Let's look at a problem like number 28. Negative 4.4x times 3. Is it negative 3? All right, thank you. Negative 3. Now, what's true about multiplication is that you can multiply things in any order that you want. So it's convenient for me to change up the order that I'm going to multiply things in. Let's do negative 4.4 times negative 3 times x. Generally speaking, like you saw in problem number 24, you're typically going to write the number part, then the variable part. So this is called the coefficient, and then the variable. So I'm just reordering things here. And here I can simplify this, right? So negative times a negative is positive. 3 times 4.4, anyone? Go ahead. 13.2. So overall, 13.2 times x. Nice. Let's try a couple more. And these are designed to simplify pretty nicely. Problem 32. 9/7 times 7/9 times k. So we've already got the number parts together, but should I just multiply those things straight out, or what can I do? Yeah, let's do some cancellation, right? The 9s cancel, as do the 7s. The 7s cancel. 1k. Now, just FYI, the 1 is understood. So if you wanted to, in fact, I'd probably prefer it, although I wouldn't mark it wrong. If you wanted to just write k, that's great. K is it. So, but either of these is fine. Either of these is acceptable. Now let me take a step back and look at this one more time. When you're multiplying numbers like this, you're multiplying what are called reciprocals. So you multiply 7/9 times its reciprocal, 9/7. And what we got was a nice simplification. We got the number 1. Certainly having a 1 out in front, or just leaving it like this, is a lot friendlier than having some ugly fraction out in front. So it's nice to be able to get rid of fractions, and one way you can do that is to multiply both sides of an equation, when we get them, by the reciprocal. So we'll keep an eye out for that. You don't always have to go all the way out to the reciprocal. We can do things like problem number 34. 15 times 4/15 w. If it helps you in problems like this, and it's up to you, if you find it convenient, you could think of this as not 15, but what else? What's a different way to think of it? 15 over 1. Why would I do something like that? Yeah, makes it easier to cancel, right? Andrew, what's left? Yeah, 4w. Cool. Thanks, gentlemen. Thanks, Andrew. All right, so let's move on and work with some of the other rules or laws that you're going to see in this section. And the next one's called the distributive property. So let me see if I can find a page reference for you on that one. Yeah, it's on page 80. But let me write it out for you. And I'll give you a couple of different versions of it. Distributive property. So distributive property is for when you multiply a number times something in parentheses like this. That number or expression out in front is going to distribute itself to both of those terms. So you'll get a times b plus a times c. Now it doesn't matter if you're adding or subtracting. If I add a times b minus c, then it'd be similar. A times b minus c, be ab minus ac. But that term is going to distribute itself to both of the expressions on the inside. Nor does it really matter if I write the a out in front or if I write the a in back. I can write b plus c times a. And again, you're still going to distribute. And I guess to make it all complete, let's write it like this. B minus c times a. And once more, that a is going to distribute. And you're going to get this. So it all works out to what's on the outside is going to multiply each term on the inside. So let's do a couple like this. We'll start with a friendly one first. That'd be problem number 36. Four times x plus 2. Where's Nick today? All right, Nick, can you distribute that for me? What would I get? Perfect. 4x plus 8. Nice, and that's what I would expect. I don't want you to necessarily write it out in any great detail. Thanks, Nick. Let's try a different one. One that, it's going to be a little bit more challenging. Well, you know what? Let's see. I'll tell you what, we'll kind of work our way up to the challenging one more slowly. We'll try problem number 50 next. Negative 1 times negative 2x plus 3. So this time, the negative 1 is going to distribute itself to both of these terms. The whole thing times this times this. Yeah, let's go front. Good, 2x minus 3. So negative times a negative is positive, so it's 2x. And then negative times a positive is negative, so 2x minus 3. Thank you. And I appreciate you volunteering. Thank you. Now, just keep an eye on this, because later on in this course, we're actually going to go the other direction. We're going to factor stuff out, like a greatest common factor or sometimes a negative. And let me just plant the seed now. Then when you factor out a negative, it's going to change both sides on what's left inside. Change both signs on what's left inside. So positive, when you factor out the negative 1, becomes negative. Negative, when you factor out the negative 1, becomes positive. So again, just some foreshadowing. All right, I did hint at a more challenging problem. That's problem number 40. 35 times y over 5 plus 8 over 7. So just like before, the term on the outside has to multiply the terms on the inside. So let's see that. In this case, it might be to our advantage to write them down. 35 times y over 5 plus 35 times 8 over 7. Now, I haven't written it with the denominator, but I have written 35 up near the numerator of the y to kind of remind you that it is really multiplying the numerator. It's probably not a bad idea to write it as 35 over 1. That way you're dealing with fractions in both of these. But at the least, write it the way I had initially, just 35 up high. Okay, so Jacqueline. No Jacqueline today? Sabrina. Where's Sabrina today? All right, Sabrina. Is there anything I can do to simplify this? I mean, that's one way to do it, 35y over 5. But I think there's probably something I would do to simplify it first. Yeah, let's do some cancellation first. So 5 goes into 5 once, and then here's 7 times. So 7y over 1. Do I need to write the over 1? No, we'll just leave that off in our final answer. And how about the next one? Is there any simplification there? So 7 goes into 7 once and into 35 5 times. Good. 5 times 8 is 40 over 1. I really don't want to see the over 1 stuff here. I mean, it's okay for an intermediate answer. And I'm not going to mark it wrong, but you know, I'd really like to see 7y plus 40. We okay on that one? Sabrina, did you see the cancellation? Okay, good. Thanks. One of the things we're going to need to work on in terms of simplifying algebraic expressions and or equations, working with them, is to combine like terms. So let me discuss like terms. These are terms with the same variables and exponents. So terms with the exact same variables and exponents. And let me just give you a few examples. And the goal is to determine whether or not they're like or unlike. Now, in all this, what matters is the variable part. The coefficient part, which is the number out in front, doesn't matter. So I could have 5x squared and negative 3x squared. Are those like terms? Yes. What matters is that they have the same variables and exponents. I could have negative 13 ABC and ABC. How about those? Are those like terms? Yes, thank you. So again, the same variables and exponents. Now, what I tried to trick you with a little bit is this. It's not written, but it's understood that there's a 1 out there. That's okay. The coefficients, the number parts don't really matter. How about 7x squared y and 12xy squared? Like or unlike? Unlike. So I think you're getting the pattern here. They have to have the same variables and exponents. Now the nice thing about like terms is that you can combine them. You can add them together. So let's see that with problems like number 68. 12y minus 15y. Now it's kind of the long way about it, but let me just show you it this once. If you really wanted to, you could factor out the y. That is, I could kind of undistribute. That leaves me with 12 minus 15. What's 12 minus 15? Negative 3. And so I'm left with negative 3 times y. Now the bottom line, and I don't want to see this. I don't want you to have to take more time on doing these things than you have to. The bottom line is this. When you're subtracting or adding like terms, you're just going to add or subtract the coefficients. You look at that, you say they're like terms. 12 minus 15 is negative 3, and that's it. So you should go from here to here. This is just demonstrating why it works. But you don't have to do that for all these different problems. Let's jump up to problem number 80 unless there's some comments or thoughts on 68 here. Yeah, please. No. I really value questions. Go ahead. All right, so you can think of this as 12 plus negative 15. All right. So because they have opposite signs, you're going to subtract their numbers. 15 minus 12 is 3. But then you keep the larger sign. So 15 has the larger sign. We'll keep that sign. It happens to be negative. All right? You're most welcome. So problem number 80. 9z minus 7 minus z minus 19z. Are all these like terms? No. So, Jenna, what are the like terms?
9z, negative z, and negative 3.
Yeah, good. Everything but the 7. So all these are like terms. Now, it may help us out to think of these as, let's see. Oh, to think of this one as having a particular coefficient. Having a coefficient essentially of negative 1. Good. So we want to combine these. 9z plus negative 7 plus negative 1z plus negative 19z. I'm not sure if that makes it easier for you guys or not. But in rewriting it using addition, I can add these in any order that I want. So I do appreciate that convenience. I'm going to start with those two. Why do you think I'm starting with those two? Yeah, they good. They both have the same sign. So add the numbers and keep the sign. Yeah, so 9z plus negative 7 minus or plus negative 20z. I'm going to continue working with these terms because those are the like terms. Well, now I have to think a little bit. So, yeah, subtract the numbers, you get 11, keep the larger sign. So 20 minus 9 is 11, largest sign is negative. So negative 11z plus negative 7, or better yet, negative 11z minus 7. If you wrote this, negative 11z plus negative 7, that's okay. This is just a little cleaner. Yeah, thanks. Oh, yeah, that's fine too. Negative 7 minus 11z. Yeah, nothing wrong with that. Um, Typically speaking, now it's not as big of a deal in this one, but later on when we get polynomial expressions like 3x squared minus or plus 7x plus 5, for instance, typically you write them in descending order, the exponents. And I guess I should have maybe an x here. So x to the second, x to the first. If I had something else, maybe a 5x cubed. But you typically write them in descending order. That's not something I'm going to mark you down on. I just do it out of habit. The only time that I might raise a little bit of fuss is if I ask you for them in descending order. But that won't be until we work with polynomials, at which point I might state that. But to your question, no, that's fine. If you wrote that, I'd be happy to see that. Okay. Oops. How did that happen? There we are. All right, number 98. Negative 16y plus 16y. Ready, set, go.
That was easy.
Yeah. All right. That was easy. 0. These are additive opposites. When you add something to its opposite, you're going to get 0. That's convenient. We're going to use that again later on. Let's do problem number 104. Negative 6 times 3x minus 6. Oh, wait. There's a little bit more to it than that. My bad. Minus 3 times 11x minus 3. Now, the tricky thing in this one is to figure out what's getting distributed where. What's going to multiply the 3x minus 6? The whole thing. Good. Negative 6. So it's negative 6 times both of those. What am I going to distribute over here? Negative 3. I suggest you distribute, again, the whole thing. So negative 3 times both of those. So try and distribute that. Figure out the like terms, and then keep going to finish simplifying that. I'm going to walk around and try and help out. Megan here today? You just like to move. It's kind of funny. You guys are such creatures of habit. It's great. You guys want the same seat every week. So what's funny, occasionally I'll get a student who shows up and is looking for a seat, but somebody who wasn't in class the first week sat in his seat and just kind of stares at him like, that's my seat. And doesn't know what to do. So it's just kind of interesting to see you guys as creatures of habit. So after you distribute, combine the like terms. looking good. I was quite happy walking around seeing a lot of right answers. So we'll distribute here. I get negative 18x plus 36 minus 33x plus 9. So we have a couple pairs of like terms. Negative 18 plus negative 33 gives you negative 51. So negative 51x. And then last but not least, 9 and 36 give you 45. So plus 45. Yeah.
Would I be able to take 3 out of both of those and then write it as like 3 in the parentheses negative 17 x minus 15? Would you want it like that?
That's a great question. And if you did that, boy, that's extremely conscientious. Sometimes I give an extra bonus point for people who are being really conscientious. That's not really what I would expect from a problem like this. But you are anticipating stuff that we'll do further. Chapter 3 or 4 maybe, when we start factoring this. But no, I'm sure that the book. Yeah, right now you don't need to factor it. Like I said though, I'm not above and beyond giving extra credit points for people who do, a little bit more conscientious work. I like that. It's like that. I wouldn't necessarily go fishing for it too much because you don't know whatever's going to motivate me. So it's just kind of random. Any other thoughts on problem number 104? We're looking okay with these. Are you feeling pretty comfortable with these? All right, that's good. So let me give you some homework for this section. This starts on page 86. So this is section 1.9. Page 86. For homework, try 19 through 49, 55 through 91, and 103.
You really like that number, don't you?
It's a prime number. Kind of like it.